So in this video, I'm going to show you about the inverse of an exponential function, which is called a logarithmic function. So everything that we know about exponential functions is just going to be flipped because a logarithmic function is the inverse. So here is the formal definition, and then we will break it down and go through, and I'll show you how to go from exponential form to logarithmic form and vice versa. So, make sure you watch the first video, the YouTube video that explains what a logarithm is and applications of it. So, definition of logarithmic with a base b. Let b and x be positive numbers where b is not equal to 1. The logarithm of x with a base b is denoted as log base b of x. So we read this log base b of x. So b is a subscript. So in exponential form, you have an exponent, which is a superscript. So the little number up in the sky, like your power, this is a subscript. And you read it log base b of x, and is defined as the exponent y that makes the equation b to the y equals x true. The inverse of the exponential function y equals b to the x is the logarithmic function x equals b to the y. This function is usually written as y equals log base b of x. So let me simplify this for you. So we've been doing this the past couple of days. So y equals b to the x. Think way back earlier this semester. The very first thing I taught you how to do is to find the inverse of a function. Your first step when you found the inverse of a function, well, you change the f of x to y. So I guess I should say your second step. Your second step when you find the inverse of a function is that you switch the x and y around. So this says y equals b to the x. So the inverse is x equals b to the y. So we switched our x and y around. However, we do not write things as x equal. We still like to write them in terms of y. So this is the notation that we write it in. Y equals log base b of x. Now, let me show you some things in Desmos. So here we are. All right, let's take a look at the purple and the black. So the purple function is exponential growth. It's just one that I typed in. It's going up from left to right. The one in the black is a logarithmic function. So these two functions are inverses of one another. And let me tell you why. So if we find a point here, look at this point here. So this point here is 0, 1. So it has a y-intercept at 0, 1. Inverses, you switch the x and y around. So now my new point is 1, 0. And notice 1, 0 pops up right there. So they are inverses of each other. Even look at their shape. So inverses reflect across the line y equals x. So if I put in the line y equals x, that new purple line, the diagonal line, you're going to have to kind of imagine that this exponential growth function is flipped over the line to make the black function, because inverses reflect across this diagonal line here. Let's go through and discuss the domain and range. My domain, and before I forget, you can find your logarithmic button if you press on functions and miscellaneous. You have two different log options here. So if you're looking for a specific log base number, you hit the one that I'm hovering around. And if not, you can just type in LOX. If you see LOG. If you see LOG by itself, the understood subscript is the number 10. So if you just see log by itself without a particular number, the understood base is 10. All right, so back to discovering why they're inverses of each other. So my domain for an exponential function was all real numbers. That is now going to be my range for a logarithmic function. My domain for a exponential function was y greater than 0. That is now going to be my domain x greater than 0. So this black one that I'm looking at here is never going to get past 0. It'll get closer and closer. So let's look at our y values like we did before. This time we're looking at the x value. So 3.49, 2.2, 1, 0.45, 0.26, 0.14. Notice my x values are getting closer and closer and closer and closer, but it'll never actually be 0. So it has an asymptote at the y-axis. So it just kind of hopefully clarifies some reasons why these are inverses of each other. And now let's go back to our paper and we're going to write down a few things. So for a logarithmic function, my domain is x greater than 0, and my range goes from negative infinity to infinity. And if you want to write this in set notation, it'd be 0 to infinity. So for a logarithmic function, my domain is x greater than 0 because there's going to be an asymptote there. It's going to get closer and closer but never touch. And then my range is going to be all real numbers. These are the inverse. I flipped them. So if you go back and look at your notes from Monday, these are the inverse of an exponential function. It's just flipped. Now, I also want to take a look at some transformations. Our transformations are going to be just the same that we've been studying all the other functions we've done this semester. So in your notes, if you haven't yet, make sure you've written down that exponential functions and logarithmic functions are inverses of each other. Underline it, bold it, highlight it, all that good stuff. Exponential functions and logarithmic functions are inverses of each other. Everything we know about exponential functions, we just flipped it for a logarithmic function. Now let's go through and do some transformations so you can see what's going to make my graph move left, right, up, or down. So the first one here, we're going to type in log base 3 of x, and 3 is going to be my subscript. So if you go down to the bottom, let me blow this up a little bit. So we're going to be doing some logarithmic transformations. Go to functions, miscellaneous, and there is your subscript there, 3 to the x power. Right. So this can be my parent function that I'm starting with. And we're going to go from the parent function to each of the functions that I have over here on my paper. So we're going to describe the transformation from here to here. So from the black to the purple. So the black is our parent function. It's the basic one. And I have a negative that's in the front. If you have a negative in the front, it's going to flip your function over the x-axis. So this is a reflection over the x-axis. So reflection over x. You do not have to graph these. I'm actually hoping you're in a place where maybe you kind of already remember what these transformation rules do. So that would be a good spot to be in. But if not, we have Desmos to help us graph it. So this one here, log base 3 of x minus 5. Hopefully you're thinking that x minus 5 is going to move it left or right, and you'd be correct. Let's take a look and see what's going to happen. So it's actually going to move it right 5. So this function is moved right 5. And the last one, let's see what happens. Log base 3 of x plus 7. Graph it to get a little visual confirmation, and hopefully you already knew, even without graphing, that my whole graph moved up 7. So all the rules that we've been studying, if you have a number on the inside, it's going to move it left or right. If you have a number on the outside, it moves it up or down. A negative in the front is going to reflect it. I can make it expand, get skinnier, compress it. All of those good things that we've been studying are the same. And the last thing I want to make sure you know how to do is how to convert from exponential form to logarithmic form. And then I'll show you also how to do the vice versa. So this is an exponential form. 2 to the 6 equals 64. If I want to write it as a logarithm, it would be log base 2 of 64 is equal to 6. And just like that, I have converted it to logarithmic form. Let's try another one. 5 to the 4th equals 625. This one would be log base 5 of 625 is equal to 4. The next one would be log base 3 of 9 is equal to 2. And the last one would be log base a half of 1/8 is equal to 3. So I've gone through it and I've converted all of these to to logarithmic form. Notice with all of them, your bases are the same. I got a base of 2, I got a base of 2, base of 5, base of 5, base of 3, base of 3, base of a half, base of a half. So it's just a matter of putting it in a new form. Last thing, let's flip it. So this time, let's go from log to exponent form. So this time, we're going to go from logarithmic form to exponential form. So convert from logarithmic form to exponential form. My base is 3. So it's going to be 3 to the x equals 243. The next one is going to be 1/2 to the x power is equal to 256. Number 3 is going to be 5 squared equals 25. And then the last one is going to be 4 to the third equals 64. So now we know how to go from log to exponent and from exponent to log. In tomorrow's video, I'll show you how to solve a logarithmic equation.